All right, so let's chat. So, on your packet, you have what is the Spring 21 released items, which means these were legit test questions. What I really dislike about when we do the practice tests online is a lot of times those feel like really scary and really tough. So what's in this packet is legit from the test last year that like last year's Math 8 students took. So when you look at question 1 here, and it won't let me copy paste it over into my smart files. I don't know why. Like I made this packet. So check out question 1. What? Oh yeah, I'm doing that. I'm pulling it up right now though also. Huh? No, I'm texting people. I'm not doing the teacher thing. So here's the deal. I want you to take 10, maybe 15 minutes. Just look through this. And guys, these are exactly what you would see on the test, aside from like some of the multiple choice. I maybe like cut the multiple choice and whatever. Most of these should feel relatively manageable. But whatever we need to go over, let's go over. Because some of this stuff we haven't practiced as much. So I want you to, on your own first, because I'm trying to help you build confidence, try this stuff out. You can skip whatever you want to, and then we'll start talking about each of these problems on their own. Tomorrow, if we want to review anything from the practice test that you took today, we can pull that up tomorrow and talk about those problems. But because these were legit the problems on the test last year, this feels more like pertinent. Connor. Sure, I mean, you can look at like what ones seem kind of scary if you like, but they're probably not that scary. We just probably need to reframe them or kind of like talk about them together. Anna? So the test is going to tell you, and most of the time we round to the nearest 10th, and I'm actually going to show you the answer key that works with the test to show you that like there's not just one exact answer you have to get. There's a range that they'll give you. So whether you use 3.14 or whether you use pi, if they haven't told you specifically what to use, there will be a little range for the answers. So we'll look at the answers together too. And guys, you can access this also. It's no like big secret. Let me move this over separately. So like the answer key is a giant PDF document that gives you examples of things that would get 1 point or like half a point or whatever. So I think what we could all figure out for the first question here is that intersection of those two functions is at 2, -4. I find it kind of funny in the Math 8 test that they tell you enter the X coordinate in the first box, enter the Y coordinate in the second. Like that feels a little redundant. Brenda? Yes, but they have to be cleared. So if you bring your physical calculator to the test, we just hit the clear button on it, and it just wipes out the memory. So it's fine. Most of you don't care what is stored on your calculator. It's as you get older and you use one of these that you can actually write programs on. If you bring your calculator to the test and I clear it, I clear out any programs that you've saved. Any games or any like quadratic formulas, any of that you've like programmed into your calculator gets cleared. Okay, but like the other calculators, they don't really store anything. All right, so take 10 minutes. I would rather you not talk with each other because your conversations keep going off the rails and you're just like chit-chatting, not really talking about math. Take a few minutes. No, I mean, like the Math 8 test is normally always the same content, but as you get older, yes, they test you on more difficult things.
Well, it's going to stay the same difficulty when it, because you get taught the same every year.
I just how good your teacher is. Oh, I need that so much.
So you guys will have calculators for both days of the test. So if you want to grab a calculator right now, you may, because you are 8th grade content, and 8th grade and above gets calculators both days.
We're built different, right?
Who what?
Us.
Who?
We're built different.
You're built different?
Yes.
Yeah.
We're built different.
Sure. I don't know what you're asking. I feel like you're...
We're not asking, I'm saying you're built different. What?
I mean, you are in a different class.
Absolute genius. I'm an absolute genius.
Yeah. You can use whatever resources you want right now. So if you want to try to look it up on your own, you can. Yeah. So if you want, or you can ask somebody at your table group. You guys can. I mean, as long as you're talking about math, I don't really care if you're talking if it's about the math. So hopefully these problems are seeming a bit more manageable than the practice test. We can just start going over this together if we want. I will probably just use my dot camera.
No good to be.
Yeah, what's up?
So I got a question. I've got a question on a question.
We should just start going over these. Which one?
The social thing.
The what?
This guy doesn't add up.
Ooh, then we messed something up. All right.
Did I do something wrong or something was printed off wrong?
Oops, let's figure out what happened there. All right, we're going through problem by problem. I know, that was not 10 minutes. Grab a seat. Yeah. All right, my caution to you with problems involving graphs. Double check the scale of the axes. Is the scale here the same on X and Y? Yes. It is going by ones. It's labeling every 2, but the scale is the same on X and Y. That's the biggest trap that will catch people with graphs, is if you don't pay attention to the scales, you might get thrown off. Now, normally these are the same. So where these graphs intersect, hopefully we all have written down 2, -4. Unless you're asking about this question, let's not shout out just random questions from the packet. We're going to go problem by problem. Patrick?
What does it mean by this solution of the equation?
What is the solution to the system of equations? The solution is always where they cross, where they equal each other. So thank you for asking that question right now. This, and you might want to make a note on here, that is your solution. No. You cannot have anything during the test aside from scrap paper.
And calculator.
Well, yeah, but Whatever works for you. All right, Beth draws triangle PQR. She also draws a square with lengths PQ, a square with lengths QR, and a square with side lengths RP. All three sides of the triangle. I just realized my music's still on. All right, so then Beth states that the sum of the areas of the two squares is equal to the area of the third square. Essentially, Beth just said that thing squared plus that thing squared equals that other thing squared. What sort of triangle is this? A right triangle. Gotta love Pythagoras.
I have a question. What do you don't understand the question? Can you ask?
Nope, not during the test. That's why we're reviewing this today and tomorrow. All right, on... Hey guys, the random chatter is not really helpful. We're all trying to make sure that we're as prepared as we can be. So if we have a question, let's raise our hand and ask a question. But if not, let's move on. So if it's a side comment, please just try to keep it to yourself. Jake?
Don't you get fired if you do bad?
No.
Oh.
Quit making stuff up, Jake. You like to, say things like they're true, and they're totally off base. Volume for a prism or cylinder would be big B times H, where big B is the area of the base. However, since this is a cone, what else is this going to involve? The 1/3, right? So 1/3 or divide by 3. It's also going to involve that 1/3 or divide by 3. Because what Max has dubbed is my best lesson I've ever taught, with the water and spilling things all over the place.
When did I say that?
During math lunch. That didn't mean you think I'm a good teacher. That just meant that was your favorite lesson.
Loved that lesson.
Yes, Anna loved that lesson.
No, Gus. My favorite lesson is when we made the boats to calculate volume.
So,
Sixth grade, I believe?
Oh yeah.
here's the tricky part here. Big B changes depending on the shape. Refocus, please. Our big B, refocus, please, Gust. You are still talking over me on an off-topic comment. Not very respectful. How do we find the area of a circle? Pi r squared. Not radius doubled. Radius times itself. What's the radius here? 3. So what is 3 squared? 9. So this becomes 9 pi. And you can write it in that order of 9 pi, or you can write 9 times 3.14 and go ahead and calculate that.
I just want to make sure you know, you told Gus that he was being disrespectful.
Yeah, but he was still trying to continue that conversation. When I said, let's refocus. And he said, remember in 6th grade when I wasn't there? Still off topic.
No, I was being mean and joking about how he wasn't there in 6th grade.
28.26. But that is the base area, the big B. We need to take that, multiply by the height, and then divide by 3, or we can multiply by 1/3. So go ahead and try that on your own. If you don't have a calculator, you might as well just grab one to practice this. The 28.26 times that 18 for the height, and then we will divide it by 3.
If you use the pi button, it's 2/7.
So this is a good one for me to show you guys some of those answers. Check it. So so the answer, since it says round your answer to the nearest integer. Remember, integer means entire number. Integer means no decimals, no fractions. So 170, you're going to get as close as that, whether you use pi or 3.14. So 169.6, you didn't round like they wanted you to. So guys, some of these are wrong answers. This still gives you a point, though. I mean, from last year's scoring, it still gives you a point. You just didn't round like you're supposed to. Or rounding for a specified value. See, So there's like some information about what they want you to do with rounding. Yeah. I forget. I think certain problems are people graded and certain problems are done by like the computer.
I do the same thing as ALA.
So 170 would have been like if we rounded to the nearest integer. Any questions on how we got to that answer?
I like his answer.
Just to have the work written out, and especially to include it in the video. All right, if there's no questions, we'll flip to the back of this page.
Sorry for the interruption. Could Lacey Abbott please come to the Perry office? Thank you.
I think I spot what you screwed up, Mr. McNeil. I bet you'll find it as soon as we start talking about it together. A researcher surveys 60 employees at a company about their highest education level. That's why there's a 60 down here already filled in for you. What's up?
I need Frank to the office for just a moment.
I heard you say Mr.
To the
Hudson,
office for just a moment.
but my brain was already rolling.
Shelby, Frank. Thank you.
Shouldn't be. Like, I don't believe sphere matters for 8th grade, but if we want to review that formula again, it's 4/3 pi r cubed for a sphere. I don't think we have anything with spheres on here. Like, I made this like this week. I made this because these are all new problems. I don't think we do spheres. Like, I don't think 8th grade includes spheres. The other thing that we can double check is if we come into here and you're fine. Don't apologize. And go to 8th grade. They give us a formula sheet, right? So if I go into the practice test, like what you guys were just in, so whatever's available here is what's available to you on the actual test when you go to take it. So the formula page doesn't actually help you that much aside from these formulas. Everything else is like conversion. So if you have a sphere problem, they give you the formula. So pyramids, cones, cylinders, and then any prism. The reason they don't give you a prism formula is it changes depending on what your base shape is. So most prisms, remember, are just the area of the base times how tall it is for a prism, right? So any shape that is copied at bottom and top. So like this is a prism because it's copied at bottom and top. Same thing. Hold on, we got too many people talking at once. Jordan. They are. Well, except pyramid, big B, that might not be a circle, whereas pi r squared is specific to being a circle. But pi r squared is big B, so these really could be the same thing. They just give you the extra help of saying pi r squared. Does that make sense? You literally at the top here says formulas. Click it. And then this expands it to make it bigger.
Well, that's really helpful.
Yeah. This is also why we're going over all this stuff today.
I didn't know you could.
I also had another question with the volume we just calculated. So, like, were you looking at, like, the 1/3 big E and then times height?
Yeah.
How is it? So, we multiply big E times height and then 1/3.
Order does not matter, actually, since it's all multiplication. So you could have done this divided by 3 and then done times your height, as long as you divide by 3 at some point, or use your 1/3 at some point. Yep, just at some point, you got to multiply by 1/3 or divide by 3, whichever you decide. Did you find it? So, coming here to fill in this table, 40 employees have a bachelor's degree. Where would that go? Under bachelor's degree in the total, right? Because it says 40 employees have a bachelor's degree. So that 40 would go down here. And guys, if we're going to talk about the lesson that was Max's favorite, we'll talk about the one that was my
It
least.
wasn't my favorite.
We'll talk about the one that was my least favorite, where I totally failed of trying to teach you guys like row and column total tables. Notice this one has both. It has totals across the bottom and totals across the side. That means that these two numbers on the bottom should add up to 60. These two numbers on the right side should add up to 60. So what number would have to be here for masters? Absolutely. Then they tell us 20 employees have at least 5 years experience and a bachelor's degree. So at least 5 years experience and a bachelor's degree. So this is where we put that 20. Guys, if you say what, I'm going to take it seriously and think that you don't know what we're saying. At least 5 years. That puts us in this row. But then, and a bachelor's degree, that puts us in the column for bachelor's degree. So that tells me this row, this column, that square. Rectangle, whatever you want to say. Does that make sense? Then, yeah, but it wasn't good. What do you mean? Please don't mess with me like that. We got, this is crunch time. 15 employees have at least 5 years of experience. Okay, so still, at least 5 years experience. I'm still in this row. But then, and a master's degree, aha. So the 15 goes here. And now we should be able to figure out everything else. What number would go? 20. Because to add up here would have to be 5. To total across the rows.
45.
Yeah, we have to fill in based off what they told us. We can then fill in the rest of it.
65.
Max.
I just want to make sure you know that was my favorite lesson. It's great.
Well, okay, yeah, I was talking specifically just about me.
Okay.
I don't care about anybody else.
My favorite lesson was probably either the boat one.
Just a wee bit
that one
narcissistic.
time where we got a substitute who didn't know what to do.
But I don't know these things that you're talking about.
And so we just got to have a free day.
I don't know these stories.
Also, in second grade. Wait, sixth grade.
All right,
Also, when we did
Hey.
robots.
try this next one on your own. Hey, we're going to stop taking a trip down memory lane. Try this one on your own, but notice that all the answers are given in radical form. So they have not done the square root yet. So if we think about the Pythagorean theorem, so if we come to find out that 52 would be our c squared, guys, and please check that this makes sense to you. We have the legs of the right triangle. So we call those legs A and B, and the hypotenuse we call C. But this is c squared. How do I get rid of the square?
Radical form.
Yeah, square root, or radical if you want to use the surfer word.
Radical, dude.
So, your answer here,
I have a question.
but there's a trapdoor. Guys, I'm on your team, right? I do not make this state test. I do not even agree with you having to take it, but I want to warn you about the trapdoors. If I do radical 52, I get 7.2, but that does not mean that your answer is A, because that's radical 7.2, which is different than just the number 7.2.
You're evil.
Not me, Max. It's the state.
Well, I need somebody
Radical.
to blame, and I'm gonna call you.
Blame the man, dude. Stick it to the man. Don't try to blame me. Guys, if we did radical 7.2, it'd be way too small. It'd be way too small. That's like 2.6, 2.7. This side can't be 2 point something. That'd be way too small.
Well, sometimes, well, Mr. Jackson, you will always say that things can lie. Numbers can lie.
This is a trap door because if you do the square root, you're going to get the number 7.2 in your calculator, but that's not 7.2, right? That's radical 7.2.
You can do it like exactly how you did it, but or if you do like different way.
I mean, this is the answer. Square root 52 is the answer.
Yeah, but if you got that, but like you did it a different way, is that okay?
I mean, you probably relatively did the same thing, but I'm going to say yes just so we can move on. That's fine. There are almost always multiple routes. Questions on that Pythagorean theorem one? I want you to read the next one on your own and actually think about it for a moment. You've got 4 points. You've got 4 points. We're trying to line up these two go together and these two go together to make lines that we will have equations that have one solution. So one solution means the lines cross at one point. Right? The lines will cross at exactly one place. Well, you have to decide what points go with which parts. If a line uses the same x values, like 5, 6, and 5, 5, what would this line then look like?
It'd be like a straight line, like a line across.
Be a straight line up. Because think about it, the same x value, 5, 5, and 5, 6,
Oh, I should mess up X again.
would be like here and here. Right? Like 5, 5, and 5, 6. They'd be on top of each other. Negative 2, 6 would be out here. Negative 2, 5 would be out here. So guys, you will have paper. You'll have just like blank computer paper. I forget if we're allowed to give you grid paper or not. I'll find out, and if we can, we will.
I think the only thing that give us is grid paper when it comes to math tests.
Yeah, I just have to double check that we're allowed to. I just want to make sure I don't break any rules. So guys, check it. If I connect those points and these points, they're parallel to each other. Although my points aren't drawn that perfect. These would be parallel. So I need to run these lines diagonal so that one has a downward slope and one has an upward slope so that they'll actually cross with each other. So this point right here is our negative 2, 6. Right? So I'm going to put negative 2, 6. But then, because I need these to cross with each other, I can't go straight across. I need to make it diagonal. So I'm going to want to connect it down to this one. Is that 5, 5 or 5, 6? 5, 5, because it's the lower one.
I'm 5, 5.
So then my other 2 points, use my negative 2, 5, because we haven't used that one yet, and the positive 5, positive 6.
It was like you had such a build-up on just for the so anticlimactic.
Because we only have like 5 minutes left, I want you to think through this one on your own. But guys, read carefully. The devil is in the details. I don't know if you've heard that phrase or if that phrase still gets said. But if you miss the details, this problem seems harder than it really is. we're modeling the distance from the car to the building. Like, what is the distance between them? But this bottom sentence is the most important part. We're starting our graphs when the car is at point A, not when the car is where it is. We're going to start when the car is at the store. So if the car's at the store, how far away from the store is it? And then is it getting further away or closer? Well, if I start, well, my car's probably not in the store.
Yeah.
So unless I drive my car into the store, through the store, I'm probably a little bit of a distance away. And then, does my distance between the store and the car get bigger or smaller or what as I drive past the library and past? It gets further, it gets bigger. So this, right there, would make sense to be the store. My car is close to the store. It's maybe not in the store, hope not. And then it gets further and further away as I drive away from the store. Try to match the other two graphs on your own. Anyone want to make a, I don't even really like saying guess because it sounds like you didn't really think about it. But Max, do you want to help me out? Sorry, Max K was raising their hand. Well, why is the library the bottom one?
Because you get closer to it as you go to the store, but then you get farther from it as you go to the school.
So as we're driving here, we're getting closer to the library, hence the distance going down, but then we pass the library, keep driving, and then our distance goes up. So that would be library here, so the distance goes away. So then what's the last one?
The school.
Why?
Because, like, you're like far away from it at the start, but then you get closer to it and closer to it.
Yeah, and then we stop at point B, right? We're like trying to get to the school. So you get closer, 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 closer. But unless I drive my car into the school, bad idea.
No.
Unless we drive our car into the school, we're still a little distance away from the school, even though we're really close. Who what? Well, if I'm going to drive it into a school, hopefully.
It better be.
I mean, I wish we still taught shop, like auto mechanics. You used to be able to walk into like any high school, probably most high schools in America, and there'd be a shop with cars in it that kids were learning how to work on cars. Yeah. Now, this makes me sound really old. This makes me sound old. But back in my day, like, we all learned how to, like, change oil and change tires and stuff like that. Now, it was an elective, so not everybody learned it, but most people did a little bit. Gus?
But it doesn't say that you stop at the store or the school. It says
Over
you stop-
time as the car travels from point A to point B.
Yeah, but at the top it says that the car passes a store, a library, and a school.
Right, but we're only graphing. I agree with what you're saying. We're only graphing between A and B. The car probably keeps going, but what we're saying is at the beginning of the graph is A, at the end of the graph is B. The car probably keeps going, and then it would probably get further away from the school. Right now it would probably turn around and go back up the other direction.
Yeah, basically.
Unless you just like circle the school. Right, if you're like practicing driving.
Actually, though, I wouldn't do that at school, though. I wouldn't do that at school. I do like that at that, like, the fairground.
If you would like to do any more of this tonight, that is totally up to you, but we will be going over this again tomorrow, and then we can take any more questions from that practice test that you guys took in Foundations.
Wait, so I shouldn't feed it to my dog?
You shouldn't feed it to your dog. It's probably not good for your dog.
I don't have
I can feed it to my tortoise. He probably wouldn't eat it though. He's hibernating, so he probably wouldn't eat it, but I can give it to him. What?
Oh, my dog is happy.
Connections we were talking about, like, I guess, and stuff like that, like, basically meat stuff, and the whole time I was just thinking about that steak I ate yesterday.